Right, a very good morning, ladies and gentlemen, and a very, very warm welcome to the Software Defined Vehicle Summit, Software Revolution in Automotive Engineering. Can we all give a huge round of applause before we begin this event? Come on, everyone. Thank you so much. Ladies and gentlemen, my name is Shamya Jigal, and today I'll be the host for this entire event. So let's kickstart this event by thanking our sponsors. So I would request everyone to please keep clapping for all our sponsors, right? So we have association partner TiHAN-IIT Hyderabad, ARAI Progress through research. We have our official media partner Autocar Professional, presentation partner Vector Infineon JLR. I want everyone to please keep clapping. Come on, come on, come on. We have technology partner Not, Ethicssoft, Valtech Mobility, CADFEM ANSYS. Identity partner Nexus in Group. Communication partner Aries. I want everyone to keep clapping. Come on, let's burn those calories now, right? And we have communication partner Aries, exhibition partner EduTech, exhibitor partner T Systems, and Interpret CS. Thank you so much to all our sponsors. Once again, can we all give a huge round of applause once again to all our sponsors? Come on, thank you. Ladies and gentlemen, to inaugurate today's conference, we have Mr. Praveen Pothumahanty, partner EY-Parthenon. He is with 15 years of global experience in automotive technology and management consulting. Mr. Pothumahanty excels at integrating technology with strategy to deliver exceptional results for clients worldwide. And to inaugurate today's conference, I would request you to please come on the stage, sir. Can we all give him a huge round of applause, everyone?
So good morning, everyone. Good morning, Bangalore. Great to see a great set of audience over here. I know it's pretty early, and like me, I'm sure everyone had to beat the traffic to get here, so well done to all of us to be here on time. I'm really pleased to see that there's a software conference or a SDV conference happening in India, and we get to be a part of it. And today, as a part of this session, as this talk, what I'm hoping to do over the next 15-20 minutes is share some of our experiences in terms of what we have learned over the last couple of years, but also, leave the stage open so that we can also learn from the participants, from the delegates over here through some offline conversations and get to know each other better, because this is a very nascent area. It's still evolving. What we know today is basis what we have understood so far, but that's not the final in terms of how it's going to evolve. I'm sure if we have this session 2 or 3 years down the lane, what we are talking today will probably look very different to what it is today. Therefore, it's very important to keep an open mind in terms of how this is evolving and make sure that we keep ourselves up to pace with the technology, and make sure that we are followers rather than we lead the path over here than just becoming fast followers, essentially. So I've got a few slides to bore you guys, because I'm a consultant. That's what I do. I always have slides ready to present some information and present some points of view. We'll try and go through this in the next 15-20 minutes. I'll try to keep it interactive. If we have time towards the end of the session, we'll probably do a few questions. If we can't do the questions, then we'll probably do it offline. I'm here the entire day. So I'm more keen to understand from the industry colleagues in terms of what their point of view is, in terms of what their take is on the entire software side of things, software defined vehicle side of things, right? So I welcome you to explore this topic with me, together with me for the next 15-20 minutes and see how it goes, essentially. Thank you very much. So I'll make a start on the presentation. There are 3 topics I want to cover broadly today. Is trying to set the tone for the day and for the sessions coming ahead, trying to look at technology. What is software-defined vehicles? It's a buzzword. People use it in a lot of different ways to suit their convenience. So therefore, I wanted to make sure that for the conversation that we are going to have, what is it that we are talking about in terms of technology that we understand today, at least where we are comfortable with what is happening. Then we'll also look at how the value chain is evolving, how the value chain is getting disrupted, or how the value chain is changing from how we know the value chain in the traditional automotive parlance. And then, what do we do in the software-defined vehicle era, when that era comes in the next 5 years, 10 years, how do you prepare yourself as an organization, whether you're an OEM, whether you're a tier 1 supplier, whether you're a technology service provider or a technology. How do we position our businesses for the future when the software-defined vehicles, the ecosystem becomes a reality, and this becomes a scaled kind of opportunity, essentially. So what is software-defined vehicles, right? There are so many definitions out there. Different people use it in different ways to kind of talk about software-defined vehicles, to say if there's some amount of software, is it a software-defined vehicle? What amount of software needs to be there, and so on and so forth. What I have done is, basis what our understanding is, the work we have done, and the way we understand it, we've kind of tried to characterize it into 3 different buckets. These are the 3 important, let's say, characteristics or attributes that you need to kind of think about as a business when you're talking about SDVs or software-defined vehicles. First one is, you need to have a modular, scalable, and digital architecture which kind of seamlessly blends your hardware and software, right? The architecture needs to be able to take in any kind of hardware and any kind of software, and you need to be able to have that flexibility to mix and match between hardware and software. That's one thing in terms of the flexibility. It needs to be scalable in terms of, you can either grow it in size or bring it down in size, essentially thinking of it as a platform approach. The platform needs to be both on the hardware side of things, but also on the software side of things. The most important thing here is that we need to start thinking of automotive product development slightly differently to what we are used to so far. Today, for example, the life cycle for automotive product development is probably around about 24 to 36 months. But with SDVs, that will look significantly different. That has to look significantly different. The life cycles will come down. The product launches will go up. The feature launches will go up. The frequency with which features will get launched, relaunched, recalibrated, that is going to change. Therefore, the scalability is very important. The modular approach from an architecture standpoint, both hardware and software, is very, very important. Second important point is connectivity. The hardware needs to become a platform for you to connect. It needs to enable connectivity to various kinds of interfaces. It could be vehicle to vehicle, it could be vehicle to infrastructure, it could be vehicle to grid, it could be a lot of other things as well as we go along. Therefore, connectivity becomes very, very important for us to understand the parlance of software-defined vehicles. One of the most important things of why connectivity is very important is, like I said in my first point, the scalable modular architecture, where you're talking about feature launches, where you're talking about upgrading your vehicles over the air, and so on and so forth. See, in some of the two-wheeler applications today in India, we do have these kinds of features, but when you think about passenger cars and much bigger vehicles, that needs to be done at scale, that needs to be done with less failure rates, and with great degree of backward compatibility, and so on and so forth. Therefore, connectivity becomes the second most important attribute when we're talking about software-defined vehicles. The final attribute from a software-defined vehicles perspective is, this is the most exciting bit for a lot of us, is the centricity around the consumer and the centricity around the driver. So the driver assistance systems are aiding your drivers in terms of helping them with features and helping them with functionalities by processing data so that the drivers are able to make better judgments and take better decisions when they're driving in the split second, both from a safety criticality standpoint and also from a comfort standpoint. Similarly, software-defined vehicles with all the connectivity features and so on and so forth should also enable us to put solutions which are customer-centric, which are custom-made to your customers, your consumers, what they want, what they like, what they dislike, and so on and so forth. So these 3 parameters become, from our perspective, at least as we speak today, a lens through which we should think about software-defined vehicles is the hardware architecture, both the digital architecture or the platform architecture, both for the hardware and software, the connectivity that needs to be enabled in the architecture, and then the features which we talk about, how these 2 things will enable your driver enhancement or driver aiding systems, and also your customer centricity, essentially. if we try to kind of double click on this a little bit more, how is the hardware architecture evolving, for example, right? The hardware architecture to enable connect software-defined vehicles is also going to go through a paradigm change, wherein it's going more towards the vehicle centralized or the centralized architecture. You know, we started off with where we were at the beginning, the distributed, which is number 3 at the top, and then probably we have moved towards domain controllers in most of the vehicle applications, but we also still have some distributed architecture. But eventually going forward, the architecture that I was talking about, alluding to in the first slide, will have to be more vehicle centralized, in the sense that you have, think about it, you have one supercomputer that is sitting on a vehicle, and then it kind of commands and demands all other functions, and it kind of interacts with a multitude of sensors, actuators, and so on and so forth. What does that mean is that the number of control units will go down in a particular vehicle, and the complexity of those control units, because as you move on, as you just go to one control unit, the complexity that resides in that one control unit will go up, which also means that the processing power, the thermal management requirements of that, all of these things are going to grow up, but also the price per that one central main computer is also likely to go up. So people in the business, tier ones who are in that particular business of doing those supercomputers or like ECUs, for example, from an automotive perspective, they will have a much more demanding job, because once you go into just one control unit, there's no redundancy in the system from a safety perspective. There's much more you have to build into the system from a redundancy perspective. But at the same time, it simplifies a lot of the architecture, and this is where we are going to be headed from an architecture perspective, because this then gives you the flexibility to add and delete features as and when you want, and add and delete more sensors, or add in more software features that is required, because everything is centralized into one programmable unit, essentially, to think about it. Now, once the hardware architecture is evolving in this particular way, the next thing we need to think about it is what is happening with the software architecture, right? Because the software will sit on top of the hardware architecture that enables your software-defined vehicles. Even in the software architecture, there will be a gradual move from what is currently a very monolithic siloed softwares. You know, you have a software architecture for each function. So powertrain function has one software architecture. The infotainment probably has one software architecture. The vehicle dynamics, vehicle stability, and all of those things, vehicle safety probably has one software architecture. This is how it has organically grown in the present day car. I mean, we need to think about how we have come to this, because the automobile has traditionally been a mechanical device, right? Over the years, it has kind of graduated with more and more mechanical systems, mechatronic systems, to get better control, better efficiencies, and better safety, for example. But what that has also meant is that all of these systems were developed independent to each other, and there is no coming together of all of these softwares and hardwares together. I think going forward in the software-defined vehicle era, that is definitely going to change, where instead of thinking of it as a vertically split, we are kind of going to integrate these things horizontally, in the sense that, you know, there's going to be a software platform approach where there is one base software that's kind of interacting with all of your hardware, be it your sensors, be it your actuators, and on top of that, you have the opportunity to build your own application layers, right? These application layers become very, very important, because that is where the differentiation is going to sit in the future. See, today, if you think about today's automobile, where does the differentiation sit? The differentiation sits in someone is able to claim better, say for example, better mileage, right? India's favorite dialogue is kitna deti hai? Or in terms of electric vehicles, people talk about what is the range you're getting in terms of one particular charge of the battery, and so on and so forth. Or some vehicles are better at acceleration, some vehicles are marketed better as from a safety perspective, and so on and so forth. Going forward in the SDV era, the differentiation for the OEMs is going to sit in the application layer, which the OEMs would want to control, because that is where you're trying to create a product differentiation for your end customer. The hardware more or less will end up becoming a commodity. You will not be able to innovate much further on hardware from a differentiation perspective. Yes, you'll always try to bring your BOM cost down, you'll always try to improve your efficiencies, system efficiencies, and so on and so forth. But the real differentiation where the customer is willing to pay will come from the software layer, the application software layer, which the OEMs will try to control or would want to have a greater degree of control going forward. This is where the software platform architecture becomes very, very important from a thought process for us to start shifting from a mechanically driven systems or a mechanically centric systems to a more software centric systems going forward. And that is where we hope that the future of the automotive is also headed, that the future car or the future passenger car is headed essentially. The second part which we spoke about is connectivity. So the first two slides were talking about more on the hardware architecture and software architecture and where this is likely to be headed and how this is evolving. The second important part is connectivity. Connectivity becomes one of the important cornerstones of software-defined vehicles for the way the vehicles are going to interact with everything around them, with other vehicles, with infrastructure, with the grids, and so on and so forth. I mean, this is a very interesting graphic, and we can talk about how the architecture works and so on and so forth, but I know a lot of you guys over here are tech aficionados, and you probably will understand this because it's intuitive. The important bit for me on this slide is the last 3 points. One is data-driven value generation. So through the connectivity is enabling us to kind of generate a lot of data about the usage patterns of the vehicles, how the vehicles are being used, abused, what are the use cases, and so on and so forth. And that then gives us an opportunity to kind of develop further, you can run some kind of AI, ML kind of techniques to optimize that data, to come up with better product designs, to come up with faster time to market, how you're servicing it, and so on and so forth. So the data-driven value generation becomes very, very important, i.e. the data that is getting generated through the connectivity and the connectivity features, that data needs to be mined, that data needs to be analyzed, and more importantly, we need to be able to draw insights, actionable insights from that data to make our products better, to make our customer experience better, to bring down our costs also. For example, as an automotive manufacturer, what is the data telling us? Therefore, that becomes a very important parameter, or that becomes a very important opportunity for us to unlock as we go ahead in the era of software-defined vehicles. Second one is new revenue streams. New revenue streams are becoming possible because of the data connectivity. We know certain cases, famous cases, notorious cases of automotive OEMs wanting to have subscription services for some of their in-vehicle features. One of the famous cases was a German OEM wanted to have a subscription feature for turning on the heated seats, right? Turning it on and turning it off, for example. Right? If you want that heated seat feature, you end up paying a subscription fee of X amount, and you only need it in winters. You don't need it in summers, for example. So there are innovative business models that are coming through, which allows you to kind of, be closer to your customers' needs. You don't want a one size fits all. If I don't need a heated seat, I don't need a heated seat. But if I only need it for certain parts of my trip, and I'm only going to use it, and I'm going to pay according to that. Therefore, that becomes very important, both from a customer's perspective, in the sense that he's able to pick and choose the features he or she wants, and both also from a OEM's perspective is that there is a new revenue stream. It could be a recurring revenue stream. It could be how you're kind of, for example, building your business models. Recently also, talking about these revenue streams, an Indian electric vehicle manufacturer also kind of announced a plan where you pay for the battery pack per kilometer, right? It's also kind of a subscription service where these things are becoming enabled because of the connectivity features, where the OEMs have a better control of what is happening with the vehicles, better visibility is the right word in terms of what is happening with their vehicles, and therefore they're able to build business models that help them also, serve the customers better, but also at the same time, protect their margins and protect their products going forward, essentially. The last important bit is the continuous improvement and deployment. This is, for example, the over-the-air updates, where I said the feature launches will have to be much more frequent. The features will have to be fine-tuned much more faster. We can't just wait for those longer automotive lead cycles. We just have to kind of act faster, look at the data, see what we can do, what software updates help us kind of fix the problem. It could be with respect to charging, it could be with respect to the range of the vehicle, it could be with respect to infotainment within this inside of your vehicle, the thermal managements, so on and so forth. Therefore, this also becomes a very interesting thing for us to think about, that your car is going through a continuous evolution as you go along, because there are software features that are being updated. I mean, just like your phone, some of us get annoyed when every time there's a software update on your iPhone or on your Samsung or Android. But maybe in tomorrow's car also, there's going to be something similar. Some features might keep getting updated on a regular basis. There could be safety reasons for that, there could be regulatory reasons for that, or there could be reasons for convenience and customer preference as well. As a customer, I might be able to change some of my settings to say that, I don't want this setting and that setting, and maybe the next time you bring your car to your dealership, your preference of settings in terms of your seats, for example, might get updated. Right? So all these things are becoming possible. These things are in the near horizon. Some of these things are already happening in the high-end premium cars, and sooner than later, they will also percolate into the volume segment, into the B segment, C segment cars as we go ahead. So this, from a connectivity perspective, I think these three are very, very crucial enablers of the crucial things that will help us also kind of understand software-defined vehicles and what software-defined vehicles mean for us in the future a lot better. Now, what is happening beyond? We've spoken about the architecture, the digital architecture, which encompasses the hardware and the software. We've spoken about the connectivity. The third bit is it has to mean something, it has to lead to something. And here is one illustrative example, right, in terms of driver assistance features, right? You have the hardware architecture where you have a multitude of sensors on your vehicle. They're sensing something. At the left bottom corner, you can see there's a camera feed and there's a LiDAR feed. These are both of these are sensors, and they're generating certain amount of data that is coming through the system. And then that goes through what is called as a sensor fusion, for example, where the LiDAR and the radar, the data from these two things are put together to give us a realistic view or the realistic picture for the onboard computers to understand what is happening. It then generates, this is a software layer, the software encapsulation layer, where it takes the data from the hardware. There is some algorithms that are running out there. There's sensor fusion that's happening. And then it detects an imminent collision, for example, and then the actuators need to be actuated to say that, we need an emergency braking that needs to happen. So there's a sensor array, there's a sensor fusion layer, there's a decision making layer, there's an action layer. This, if you think about the way all of this is set up, is being enabled by the digital architecture, which is the hardware and the software and the connectivity features. Both of these two things culminate into giving us a tangible result, like for example, an emergency brake assist kind of a feature that we see in the vehicle. And this is just one example of a feature to give you an illustration of what all happens in the background in terms of the architecture of the software-defined vehicle. But going forward, I'm pretty sure there'll be many more such features, not just from a safety perspective. It could also be from other elements within the car. It could be personal preference, consumer preferences for infotainment, for comfort, for HVAC systems, for thermal management, and so on and so forth. Really talking about it today, the opportunity space seems to be unlimited. It really comes down to, what is it that we can do within reasonable time frame and within reasonable cost, essentially. Now, we looked at the technology to understand what is software-defined vehicles. We spoke about the three attributes for software-defined vehicles: the hardware side of things, hardware software side of things, the connectivity, and the customer centricity and the driver assistance systems. What is happening on the value chain side of things, right? How is this kind of a development disrupting, or how the value chain is evolving, is something we'll try to focus for the next 5 to 10 minutes. Now, if you talk about the software value chain, right? The software architecture, most of you guys here will know there's going to be a base software, there's going to be a middle level software, there's an application level software, and then there is the cloud connectivity and so on and so forth. Traditionally, for each of these layers, you might have had suppliers who would have done only those individual bits. From the vendor's perspective, they would have done the software and the firmware for your base software, for example, is a separate vendor. Then you had your middle layer, someone else would have done it. Your application software, someone else would have done it. And your cloud, someone else would have done it. What we are seeing today is that some of the tier twos in the software-defined vehicle ecosystem are sensing an opportunity over here to kind of move up the value chain, in the sense that some of these tier twos, who are your technology providers, who are your providers of your chips, for example, chips with some software on it, right? They see an opportunity space where they can directly, have a conversation with the OEMs to kind of help OEMs build what they want, essentially. So what we're beginning to see is that differentiation or that segmentation in terms of I'll only do the base software, the middle level software, or the application software, that seems to be going away, and there is a little bit of overlap between people who are trying to do this. And then we have, for example, some companies which are trying to play across all of these segments like an integrated solution provider, for example, right? That is the North Star for a lot of companies in this space to get to, wherein they are able to provide end-to-end solutions from a software perspective, the entire technology stack, as we call it, right from the base software hardware layer right up until the application layer, and also providing the cloud connectivity, for example. What this means is that what we are beginning to see, and this trend is something that is very, very recent, and I really do not know if this is going to hold good over the next 5 years, but we know the automotive value chain as a linear way where we have the tier 3s, tier 2s, tier 1s, and the vehicle OEMs, right? The tier 2 space tends to be most of your technology providers, where a lot of this software development also happens. And then you have a tier 1 in the traditional space who would have integrated all of these things into a system, right? Take, for example, an emission control system. You would have had a software and an ECU for an emission control system. You would have had some catalysts and some actuators. And the tier 1's job was to kind of integrate all of that into one system and also integrate into that vehicle. Now, with software-defined vehicles, what is happening, and these are some very early trends, is that, as I said, the differentiation sits in the software layer, the application software layer. So what that means is that the OEMs are very, very keen to kind of keep that application software development with them, because that is where their differentiation is going to happen. In the traditional way of doing things, they would have gone to a tier 1 and said, give me this system, both the hardware and software, it's your responsibility. And the tier 1 would have given them something, and they would have integrated it into their vehicle, and that's the end of the story. But going forward, the trend is that the OEMs would want to own more of that space, especially the application software, because that is where the differentiation is going to get created. Now, what that means is that the tier 2s who have been your traditional, technology providers, these could be your the Infineons of the world, these could be the Renesas of the world, the semiconductor guys of the world. These guys have started directly engaging with the OEMs, or the OEMs have started reaching out directly to these people, in a way kind of marginalizing the tier 1 space in the software-defined vehicle space. This is because OEMs want to have better control of the product from a software perspective, and they are saying, hey, we want to have direct conversation in terms of what is going on to the hardware, therefore we can design our software accordingly, for example. From that perspective, we are seeing that the tier 1 space is getting squeezed out a little bit, and that we have kind of named it as tier 0.5 kind of suppliers. It could be anything. The whole point is that the space for that tier 1 is becoming narrower and narrower. Today, the tier 1s are still relevant in this space because they still hold a very important skill set in terms of integrating the systems into the vehicles, for example, because the OEMs still depend on the tier 1s to do it, and the tier 2s currently may not have the necessary capabilities to integrate their systems into the vehicle integration layer, for example. That is getting squeezed out. I would expect the tier 1s to bounce back. They would also try to do more of the technology business. They probably do some mergers and acquisitions backward to kind of also have some control on the technology business. At the same time, the tier 2s will also try and get into the vehicle integration side of things. So this is an interesting space for us to kind of keep watching about as to how the dynamics between an OEM, a tier 1 and a tier 2 is likely to evolve in the software-defined vehicle space. As we see today, as of today, we sense that the tier 1 space is getting squeezed out slightly. But like I said, it's early days, and I'd expect the tier 1s to bounce back and push back on this. And at the same time, the tier 2s also to try and get more and more into the vehicle integration space, essentially. Now, we've looked at technology, we've looked at what is happening from a value chain perspective, what are some of the dynamics that we are observing, or we have observed so far in the automotive value chain from an SDV space. How do you kind of navigate these things, right? Because this is all very uncertain times right now. Just like with electrification, what do we do? Do we do this? Do we not do this? With SDV, what do we do? Do we get into SDVs? Do we not get into SDVs? If we get into SDVs, which part of SDVs do we get into? This is a bit of a consulting side. I apologize for that. It's a 2x2 matrix to kind of say where do we kind of actually play, right? Depending upon where your interest is, what your capabilities are. I think it's I don't know if this pointer is working, but it's very simple to kind of think about it. Either you want to be in the software differentiator space or in the high-tech space, because the bottom two quadrants are more or less saturated. These are products that have been there in the industry, and there are enough players out there, and these are either commoditized products or standardized products. Some of them are safety critical, and some of them may not be safety critical. The real question for us, if someone wants to kind of get into any of these areas, is to say, where do we want to essentially play? What is our business goal? And what are the skill sets that we require to kind of build that business, for example, going forward? Do we want to be in the software differentiator space, which is relatively, if you compare it with the high tech, which is relatively less of an effort, but still it has a very high differentiating value? This could be your in-cabin experience, this could be your infotainment systems, this could be other consumer experience related softwares that are a part of your vehicle solution, for example. But the true North Star for any company in the SDV space is probably getting into this right top quadrant, into the high-tech space, which is where all the excitement about autonomous vehicles, driver assistance systems, cloud connectivity, and so on and so forth is happening. So as a business, where do you want to go, or what are the steps, or what is the roadmap that you take? Maybe you're currently in the standardized products quadrant. Do you go from standardized products to software differentiators and then to high tech, or do you make the leap from standardized products to high tech? Similarly, from commoditized to software differentiators to high tech, how do you go about doing that? I think that is something all of us will have to be very cognizant in terms of the path we're going to take, the resources we're going to commit, and what is going to be our chances of success. I don't have a silver bullet to say this is what we need to be doing. It will depend upon each individual case in terms of what the business aspirations are. But I thought I'll lay it out over here so that we get a sense in terms of what the lay of the land today is, so that we are better prepared to answer these questions ourselves in terms of where our SDV journey needs to go going forward. And finally, once we have decided on what our SDV strategy is going to be, where is it that we are going to play, there are three important elements that we need to solve for. One, we always have to make sure that there's a market for what we are building, product, services, and there's enough of the market which is willing to pay for the product or the service that you're going to offer. Second one is, we need to start thinking about the organization we need to build. See, automotive organizations have traditionally been mechanical heavy, manufacturing heavy organizations, not just from a process point of view, but also the way they think, right? That needs to go through a paradigm shift. We need to build dedicated software organizations as part of automotive value chains, right? Automotive OEMs will need to have dedicated software organizations which think differently, which think different to the way the current manufacturing industry thinks. We need to be more nimble, we need to be more agile, we need to be more adaptable to the constant evolution in technology, right? So for example, today, AI and ML is a very buzzword everywhere, cutting across industries. I was very recently at a conference in the US. We're already talking about the next technology. We're talking about quantum computing. Would quantum computing come in and disrupt the automotive value chains? Is it likely that it's going to happen, or is it not? So we have to be very, very nimble in the way we are kind of building our organization. And finally, also on the technology side of things, the choice of technology platforms you make from a hardware perspective and from a software perspective, that becomes very, very crucial, because we need to keep them independent of each other, but yet somehow they need to be speaking to each other, so that your product development continues at a rapid pace. And the technology choices we make today might be set in stone for the next 2 to 3 years, if not more. And therefore, what technology choices we make over there also becomes very, very important for us to define our software-defined vehicle journey. Then, to sum it all up, in terms of what we are thinking, or what our understanding has been in the software-defined vehicle space, and what are the key takeaways from our perspective. One is the hardware architecture that needs to be given a rethink, in the sense that it needs to be modular, it needs to be scalable, and it needs to be adaptable in terms of bringing in new hardware features or software features going forward. Your software strategy needs to be thought of. Your software needs to be thought of as a software platform going forward, cutting across multiple domains in the vehicle, not just as being siloed software developments for powertrain separately, infotainment separately, vehicle comfort features and vehicle dynamics separately. It needs to cut through. You need to have a common software platform that kind of enables the differentiation to happen at an application layer from an OEM perspective. One other important thing I think we'll touch upon in some of these panel sessions today is that connectivity, we've spoken about it, but as we start putting more and more data into the cloud, we also need to think about what is going to be our strategy for the cloud. How are we going to manage that cloud? How are we going to manage the security of the data transfer between the cloud and the vehicle, cyber security related features, and what is going to be, your strategy? What are the tasks you're going to perform on the vehicle, online, in real time? What are the tasks you're going to perform in the cloud? What data is getting pushed into the cloud? What is the latency that is available with respect to the networks, the network coverage that is available? How are you going to manage all of these things, right? These are all pertinent questions today as we speak, not just in India, globally, people are still kind of thinking about these challenges, and these will also definitely have a greater implication on the overall software-defined vehicle and the way it is going to evolve in the next 5 to 10 years. I truly believe that we are in a very exciting phase of automotive development. We're coming off of 100 years of mechanical-centric automotive product development, and we are probably we are ushering ourselves into an era where software will become the cornerstone of every automotive, not from a consumer experience perspective, but also from a product development experience. Thank you for your time and for the patient listening. I think we are out of time, so if there are any questions, I'm available offline. More than questions, I'm happy to discuss other viewpoints, because like I said, this is still a very evolving field, and we are also learning as we go along. Thank you very much. Thank you once again.